Hi, so let's go over the double angles that we see up here. I do have this handout attached. If you would like to print it out, you can. Double angles, pause if you need to write them down. Let's begin with number 1. So here we have cosine theta equals 4/5, and we have the information to tell us what quadrant. Start there, Q4. So now I know I'm going to have to start in Q4, so of quadrant 4. Here's my triangle in quadrant 4. So now that I know I'm down here, cosine in quadrant 4 is 4/5, so that's adjacent. Here's theta, adjacent over the hypotenuse. This is going to be a 3, 4, 5 triangle. Don't forget that that 3 is going to be negative. It's going to help you later on. Okay, so this is 2 theta. 2 theta is up here. We're going to copy that down. 2 sine theta, cosine theta. So let's figure this out. Sine of theta is -3/5. Cosine of theta is 4/5. And now we just have to do the math. I'm going to put 2/1, so that looks like a fraction also. Multiply across the top, that's -24. Multiply across the bottom, 25. Finished. That is your double angle formula for cosine. Let's slide down one and let's check out the double angle formula, or for sine, double angle formula for cosine here. Okay, so now what we are going to do is we are going to do build our triangle first in quadrant 1. So here I am in quadrant 1. It's my triangle. There's theta. Tangent of theta is 3. Okay, let's turn that into a fraction. That's 3/1. Opposite over adjacent is tangent, and that means I have to figure out what this guy over here is, right? So let's do side squared. Leg squared plus leg squared is equal to hypotenuse squared, right? A squared plus b squared is equal to our c squared. 9 plus 1 is equal to c squared, and that's 10. Take the square root of both sides, and c is equal to radical 10. So I'm going to put my radical 10 right here. Now I've completed my triangle, and now I'm going to go back to my cosine. Cosine 2 theta. We can use any one of these 3 formulas that we want to. Maybe I will choose, I don't know, maybe I'll go for the first one, because why not? So here for our first one, it's going to be equal to cosine squared theta, that's how I would say that, minus sine squared theta. What this actually means is you're going to find the cosine of theta and then square it. We could have put the square outside here if we use parentheses, but this is just another way to write it, the more common way, so we'll get used to writing it this way and saying cosine square theta. But that means you're going to find cosine of theta, which is 1/radical 10. And once we have that, we are going to square it. Minus sine square theta, which means find sine of theta, 3/radical 10, and square that. Okay. I didn't bother with rationalizing here because I'm squaring the denominators, which are the radicals, squaring everything. Square your numerator, that's 1. Square the denominator, and that kind of cancels, right? So that's just going to give us 10, minus square your numerator, square your denominator, that kind of cancels, so there's 10. 1 minus 9, that's going to give me -8/10, and that's going to be -4/5 when I reduce it. You know what? I have space here. Let's do one more. Just cause we can. So let's do cosine 2 theta is equal to 1 minus 2 sine square theta. 1 minus 2 times sine square theta means, hey, find sine theta and square it. So I'm going to come over here, and sine is going to be opposite over hypotenuse, so that's going to be 3/radical 10. And I'm only squaring the fraction, whatever sine theta is, and then I'm going to double it. So that's equal to 1 minus 2 times, square your numerator, 9. Square your denominator, and that's 10. So this is going to look like 1 minus, multiply across the top, 18 over 10. Well, I'm going to rewrite this with a common denominator, and I'm going to make that 1 10 over 10. Okay, so I do that later on, you'll see. So 10 over 10, so 10 minus 8, that's negative 8 over 10. Oh, deja vu, there it is. And that's going to equal negative 4/5. Okay, so that is your cosine double angle formula. Let's move on, and let's try number 5. So number 5 is an example of our double angle formula for tangent, so tan 2 theta. So first thing we have to do is use this equation in this quadrant, build our triangle. This is Q4. So let's find out where Q4 is. It's going to be over here somewhere. There's my angle. Okay, so this is cosine, and cosine is adjacent over my hypotenuse, and so this is a 5, 12, 13 triangle, but remember, that's a negative 5. It's just going to help us later. So tangent. So flip back over if you need to, and we're going to write down that tangent formula. Tangent 2 theta is equal to 2 tan theta divided by 1 minus tan squared theta. Okay, so we're only using tangent. Sometimes when I do tangent, I square the 2 pieces that I'm going to use, so my eye doesn't even go to the 13. Okay, moving on. 2 times tangent is opposite over adjacent, so it's going to be negative 5 over 12. Remember, we're multiplying. It almost looked like minus, so I had to do that. 1 minus, well, here's my tangent, right? So it's negative 5/12, and I'm going to be squaring it. If I'm multiplying 2 fractions, I may as well make that 2 look like a fraction, and that's going to reduce, and my numerator is going to be negative 5/6. My denominator. Okay, I'm going to leave this 1 for a moment. Here's my minus. When I square this, that number is going to be positive. Square my numerator, 25. Square my denominator, 144. And let's just kind of put out there that this is going to have to be 144 over 144. All right, 144 minus 25. Well, I'm actually doing this at night and I'm tired, so let's see. 144 minus 25, I'm going to need my calculator soon anyway. 119. 119 over 144. Okay, so let's figure this out. I'm going to do top divided by bottom. So I'm going to do my, I'm putting everything in parentheses, negative 5/6 divided by, what was that, 119? 119 divided by 144. I don't even need to close the parentheses at the end. I'm feeling kind of lazy. I got some crazy number, and I'm going to math, frac, turn it back, math, enter, enter, and my answer is negative 120 divided by 119. Okay. At this point, please do the next 4 problems on the bottom. So we're going to do 7 through 10. Pause the screen because I'm about to go over them with you real quick. Okay. Number 7. Q3, build your triangle in Q3. Tangent, make them both negative. It's a 3, 4, 5 triangle. This is the formula I decided to use for cosine for no apparent reason. And I plugged everything in and I got my 7 over 25. Number 8 is the full angle formula for sine. Use this equation and build your triangle in quadrant 4. Here it is. Don't forget that the negative goes with the 7. No negative with the 24. Plug in your fractions. This is our crazy fraction answer for number 8. Moving on to number 9. I'm using this cosine equation, and I'm going to build my triangle in Q2. So here's Q2. Cosine is negative 4 over 5. It's a 345. That guy's positive, right? Because he goes up. So then I'm going to have my tangent formula. So here's my double angle formula for tangent. And again, like I said, I do sometimes circle the two parts that I'm going to need so my eye doesn't go anywhere else. So it is opposite over adjacent. Here it all is, and it worked out to be negative 24 over 7. My very last guy over here. Super fuzzy. Let's see if I can make this any better for you. That's a little better. Okay. This builds my triangle in quadrant 4. So here I'm going to put stuff in quadrant 4. Opposite over adjacent. That's the guy that gets the negative. Kind of we weren't sure at first. And it's a 3, 4, 5 triangle. For cosine formula, I decided to use this formula this time. Why not mix it up? So I get used to all of them. And then I put everything in here. And my answer is 7 over 25. Do you want to know the answers for the first ones? Did we not give them to you? I think you know. So what do we need the answers for? 2, 4, and 6. In case you don't have them, let me dig them up somewhere. 2, 4, and 6. The answer for number 2, negative 336 over 625. The answer for number 4 is 161 over 289. And then the answer for number 6 is 24 over 7. In case you don't have those, you do now. Okay, good times. Take care.